Hello, everybody. Today we are going to be talking about multi-step conversions. Now, if you're a hybrid student, we have already talked about this in class, so this is just a little bit of extra review if you want to go back and hear live how we solved these problems. But if you're a virtual student, then this is super important that you watch this video because it's going to help you with some of those more extended conversion problems. So let's just go ahead and jump right in. We are going to be using the same method that we learned in the previous conversions videos, and we are just now going to be applying it to longer problems. So let's start here with this first problem. It says convert 428 miles to inches. Now, you probably, just guessing here, don't know how many inches are in a mile, but it's a lot, right? There is something that we do know, however, and this is something that they made you memorize from a small age for some reason, but we don't know how many miles or how many inches are in a mile, but we know how many feet are in a mile. We know that there are 5,280 feet in 1 mile. Then hopefully we know how many inches are in a foot, right? There are 12 inches in 1 foot. So if we look at this problem, if we don't know how to get from point A to point B, what we need to think is, okay, well, maybe there's a halfway point. So maybe I'm not going from A to B, I'm going from A to B to C, and C is that final place that I want to get to. So let's see what that looks like when we set up the skeleton or the conversion skeleton. We still start with our given number on the left-hand side, 428 miles. We set up our empty fraction, okay, and the unit that we are canceling out of goes on the bottom. So miles is going to go on the bottom. The thing is, I don't want to go straight to inches because I don't know the conversion factor between inches and miles. So this is where I'm going to add feet as like an intermediate step. So feet is going to go there. So then miles will cancel out because they're on opposite sides of the fraction, and then I'm going to be left with feet. But I didn't want to solve for feet. I want to solve for inches. So I have to add another step. Now this time, the unit that I want to cancel out of is feet, and the unit that I want to go to is inches. So the miles are going to cancel. Feet is going to cancel, and I'm going to be left with inches, which is perfect because that's what I want to be left with. Okay, now we can go back and we can add in all of our conversion factors. So when we have feet and miles together, we need to use this conversion factor because this is the conversion factor that relates feet and miles. So again, we have to be careful that we keep the number with the unit, and by that I mean there are 5,280 feet in every 1 mile. There's not 1 foot in every 5,280 feet or miles. You know, I can't even explain it the other way because it's just so confusing. Make sure you keep the 5,280 with the feet and the 1 with the miles. Okay, going on to the second conversion factor here. This time we have inches and feet, so we're going to be using this conversion factor, and we have to keep the 12 with the inches and the 1 with the feet. But now we have everything all set up. Our units are going to cancel out. All we have to do is solve. So we multiply everything across the top. 428 times 5,280 times 12, and we get, hypothetically, a really big number. Right? We know that there are going to be a lot of inches in 1 mile, much less in 428 miles. So we get this big number. We don't have to worry about the dividing, right? Because there's ones on the bottom. So we get this really big number, 27,118,080. That's what we get. That's how many inches are in a mile. Unfortunately, we have to think about significant figures. So we're not done yet. Our original given information, so that's the 428, has 3 sig figs. the 4, the 2, and the 8. So we have to make sure our answer only has 3 sig figs. So we start counting our sig figs from the left, right? Just like you would read left to right. So the 2 is going to count, the 7 is going to count, and this 1 is going to count. But then we are sort of cut off. So none of the rest of those digits are going to play into the significant figures. The 1 does not round up this 1, so we're good. The answer is going to be 271. Just kidding! No, we have a really big number. So whenever we cut off here with our sig figs, that doesn't mean the number ends. That just means that all of the other digits get turned into zeros so that we still have the right size number, but it's a different number of significant digits. So we still have all of these zeros here because we want to have the same size number. We want 27 million-ish. All right, so our final answer is 27,100,000 inches. All right, let's do the next one. This one might be a little bit more straightforward for you. This one just has to deal with time, which you guys have been converting with time units forever and ever and ever. So let's say that you are 15.7 years old. That's probably a lot of you in this class, if I had to guess. Many of you are on the verge of becoming 16, or maybe you're still 15, who knows. Anyway, you're probably around this age as an average. If you're that many years old, how many seconds is that? Well, we have to think, okay, is this going to be a big number or is it going to be a small number? Yeah, of course. It's going to be a huge number because there are a lot of seconds in a minute. There's a lot of minutes in an hour. There's a lot of hours in a day. There's a lot of days in a year. And we have 15.7 years. So that's our initial value. That's our given in this example, 15.7. And we're going to convert to seconds. But I don't know about you guys. I do not know how many seconds there are in a year. I know a lot of other time-based units, like I know that there are 365 days in 1 year, and I know that there are 24 hours in 1 day, and I know that there are 60 minutes in 1 hour, and lastly, I know that there are 60 seconds in 1 minute. So I'm going to use all of those conversion factors here to do this super long multi-step conversion because I do not know how to get straight from years to seconds. So I have to consider intermediate steps. All right, so I'm setting this up. I want years to cancel out, so years goes on the bottom. I'm going to go to days first. All right. So my years are going to cancel out, which is good. I don't want those. But now I need to cancel out of days. So days goes on the bottom. And now hours is going to go on the top. All right. Days is canceling. Perfect. Don't care about it. Now I'm in hours. I'm not done yet. I need to get all the way to seconds. Well, I know that there are 60 minutes in an hour. So I'm going to cancel out of hours and go into minutes. Okay. But again, I don't want to be in minutes, so the hours cancel out, which is good, but I still need to cancel out of minutes and go to seconds. And guess what? That's what I want to be in. I want to end up in seconds. So I've set up this big skeleton structure here. And now I need to go through and add in all my information. Well, there's 365 days in 1 year. We know that there are 24 hours in 1 day. We know that there are 60 minutes in 1 hour. And we know that there are 60 seconds in 1 minute. So once we fill in those conversion factors, all we have to do is multiply. You'll notice that everything in the denominator is a 1. That just works out for us. So we just solve 15.7 times 365 times 24 times 60 times 60 again. And our final answer is really big, just like we predicted. 495,115,000 4,200 seconds. But do we get to keep all of those digits? No, we still have to consider significant figures. 15.7 has 3 sig figs. So our final answer needs to have 3 sig figs. So the 4 will count, the 9 will count, the 5 will count. Then we're going to be cut off. That 1 is not going to round up the 5, so we're just going to be left with 495, right? Nope, just like in the last problem, after we cut off our sig figs, we still have to add all of those zeros in order to keep the right size number. We don't want to say that there are 495 seconds in 15.7 years. That doesn't even make any sense. All right, that last step is always to check that your answer makes sense, and we know that ours does. We are expecting a lot of seconds in a year, or 15.7 years. All right, let's do some more. A table is measured to be 40 inches by 28 inches. What is the table's area in feet squared? My recommendation in problems such as this is to always convert these first. We know that if we're going to find area equals length times width. But we don't want to complete this calculation. We don't want to multiply length times width until we're already in feet. Right now we're in inches. So we need to convert inches to feet, and then we need to multiply them. All right, so this isn't necessarily a multi-step conversion, but we need to complete multiple steps in order to get the final answer. So the first thing that we're going to do is convert 40.0 inches and 28.0 inches into feet. So inches is going to go on the bottom of both of them, and feet is going to go on the top of both of them because that's the unit that we want to get to. We're going to end up in some number of feet. All right, then the question is, oops, that's a T. The question is, well, how many inches are in a foot? Hopefully you know, 12 inches in 1 foot. So we need to take both of those numbers and divide by 12. So 40 divided by 12 is 3.33. This is with the correct number of sig figs, right? I get 3 sig figs. So my answer over here, 3.33, needs 3 sig figs. So in this bottom problem, I need to take 28.0 and divide by 12. And again, I get 3 sig figs. 28.0 has 3 sig figs. So my answer is 2.33 feet. Finally, what I need to do, because area is length times width, I need to take these two numbers and multiply them together. So area equals 3.33 feet times 2.33 feet, and you're going to come up with an answer. 3.33 times 2.33 equals 7.7589. But sig figs. All right, so with sig figs, I get 3, right? Both of these numbers have 3 sig figs. So my answer can only have 3 sig figs. So 1, 2, 3, and then I'm cut off. Here, though, this 8 is going to round the 5 up, so my final answer will be 7.76 feet squared. We had feet times feet, so that's going to give us feet squared, and this is my final answer. Now, if you want to do this in one step instead of breaking it down, you have to be really careful because of the feet squared. Now, if we took 40 inches and we multiplied it by 28.0 inches, just for area here, so area equals 40 inches times 28 inches, we would get 1,120 inches squared. And here we can convert from inches squared to feet squared, but we have to be careful. There are not 12 inches squared in 1 foot squared. That conversion factor no longer holds true. So let's just cross out this whole center piece here. We have to be more careful. I'm just going to erase it. When we want to convert 1,120 inches squared into feet squared, we have to break it down. Inches squared is like inches times inches. So I can't just put inches on the bottom once. I have to put inches on the bottom twice and feet on the top twice to get that square. So there's 1 foot, 12 inches, 1 foot, 12 inches, right? And then I can go from there. You could also do inches squared times 144 inches squared in 1 foot squared if you wanted to condense it that way, right? Either way, you're going to end up with the same answer, right? 1120 divided by 12 equals 7.78. So we are right in that same realm. The difference here is because of rounding, okay? So because of rounding, our answers look a little bit different, okay? Here, 1120 divided by 144, we're going to get the same thing, 7.78. And this is both feet squared. Okay, I recommend that you use the top in red. This way is going to be way easier for you to keep track of. Before you do any calculations, you should convert to the right units. So before you ever multiply anything together, let's go ahead and convert those units, okay? So that's how you do something with area. Let's do a couple more here, last two. Let's say a small swimming pool holds 153,289,000 milliliters of water. I want to know how many meters cubed of water that pool holds. Now, you might be thinking, what the heck? How do I get from milliliters to meters cubed? Well, we've started talking about density. You should know that 1 milliliter is the same thing as 1 centimeter cubed. Milliliters, that's like when we measure liquid stuff. Centimeters cubed, that's when we might do volume equals length times width times height. But these are the same unit. 1 milliliter equals 1 centimeter cubed. That's super important. So then once we're in centimeters cubed, it should be pretty straightforward to go to meters cubed. Okay, so let's go ahead and just show this conversion really quick. For every 1 milliliter, there is 1 centimeter cubed. So we get the same number. So now we are in centimeters cubed. Oops, that did not come out right. Centimeters cubed. But now what? Now we need to go from centimeters to meters, which is our metric conversions. So you might be thinking, oh, that's really easy. We just need to move the decimal twice. And since we're going down the ladder, right, meters is up here, centimeters is down here, in between is decimeters, right? So we're going 1, 2 jumps down. You should only have to move your decimal place twice. All right, the difference here between the meters and the centimeters, since we've got 1, 2 jumps up to get from centimeters to meters, you might be thinking, oh, we only need to move our decimal point. Let me change my color. We only need to move our decimal point 1, 2 times, and boom, we're done. But remember, we are dealing with cubes. So there are not 100 centimeters cubed in 1 meter cubed. That's not true. There is 100 cubed. So we need to do this decimal jump twice, or 3 times total, 2 more times. So we've done it once, so that's 1, 2 hops, and then another 2, and then another 2. And this is going to be our final answer. So our answer here now is 153.289. And we can forget about the rest of the zeros because they are no longer significant, right? Our first number has 1, 2, 3, 4, 5, 6 sig figs. So our answer needs to have 6 sig figs. And Bob's your uncle. There's the answer. So you have to be really careful with those squares and those cubes that you're moving your decimal the right number of times. All right, last one. We've got miles per hour and kilometers per second. Oh my God, we want to know how fast. So how many miles per hour is 12 kilometers per second? So you'll notice now our given information is in fraction form. So this is going to yield some different results. Now we're going to have units on the top and the bottom that we need to cancel out of, because I want to end up in miles per hour. Right now I'm in kilometers per second. So I don't know about you guys, let's just get the miles out of the way, right? Because it says the conversion factor right here. We know if we put kilometers on the bottom, then kilometers will cancel out and we can go into miles. So that'll be good, but then we're in miles per second. That second is still there. We still need to get rid of that second. Here's the tricky bit. Right now the seconds is on the bottom. So if I want to cancel out the seconds, I have to put it on the top. This is contrary to what we've sort of been learning, but it makes sense, right? It has to be on the opposite side that it started from. So if seconds is on the bottom originally, I have to put it on the top if I want it to cancel out. And I'm going to go from seconds to minutes, and then I'm going to go from minutes to hours. All right, so now I've got my skeleton set up here. I should end up, the only things left are miles over hours, or miles per hour. This is what I want to be left in. So then I fill in my conversion information. There's 1.61 kilometers in 1 mile. There are 60 seconds in 1 minute. There's 60 minutes in 1 hour. But I do have to be careful when I am calculating this all out. I have to multiply across the top. So 12 kilometers times 60 times 60, and you get a number, and then you divide that number by 1.61, and that is your final answer. I got 26,832 miles per hour. But I only get 2 sig figs, so I need to round my answer to 2 sig figs. I can keep the 2 and the 6. The 8 is going to round that 6 up, so my answer is 27, right? Oh, you guys are too smart. I got to put those zeros in there. 27,000 miles per hour is my answer. That's pretty fast. Can you imagine going 12 kilometers in a second? Some people run a 5 kilometer and it takes them 30 minutes. All right, so this is pretty fast. 12 kilometers in a second. This is like jet speed. All right, remember that you can pause this video, you can rewatch this video as many times as you want, you can put it in slow motion, and please make sure that you are asking questions in office hours if you are still confused about how to complete these assignments.